Hey guys, hope everyone's doing well. Happy Tuesday. Okay, so we are going to go over this distance time graphs gizmo. Just so you know, make sure you are correcting your gizmo as you go along because we will have a concept check on Thursday for this gizmo, and that will go into the SEP bucket for grading, okay? So, prior knowledge questions. Max ran 50 meters in 10 seconds and Molly ran 30 in 5. Who ran further? Max did run further, but Molly was faster. Molly ran about 6 meters per second, where Max ran 5 meters each second. Okay. Now we have our gizmo warm-up, and this is really just getting you used to the tool. So you click this green start button. What happens? The runner runs from left to right for 4 seconds, stopping at that 40-meter line. That vertical probe, so this green vertical probe, that just tells you exactly where the runner is at any time. So it's asking you at what position was the runner at 1 second. 1 second, the runner was at 10 meters. What are the coordinates? That's 1, 10. Okay, so it's telling you that how your variables and your coordinates all kind of go together. At 1 second, the runner was at 10 meters, so that coordinate pair is 1, 10. What is the runner at the 30-meter line? That's at 3 seconds, and the coordinate pair is 3:30. Activity A. Okay, so if a distance time graph contains the point 4:15, what does that tell you about the runner? This tells you that 4 seconds of running, the runner was at the 15 meters from the starting line. Using the green probe, what can you see in the stopwatch at the moment? The runner would be at the 20-meter line facing left, and the stopwatch would read approximately 1.5 seconds, okay? Which is a little different than facing left is a little different than what we'll see throughout the gizmo. Look at the image below. What must be true about this runner's graph? So because of where this person is and the stopwatch, it tells us that there must be the point 3.25, 25. This is the big idea. If you put like 23 or something like that, that's fine. The big idea is just that the runner and where they are at a certain time and distance dictates the coordinate pair, okay? You may have also talked about how it might have a positive slope because the runner is facing forward in the image versus backwards, okay? Now, your graph may look a little different than mine, but it was just asking you to create a graph whose runner starts 20 meters from the starting line, runs to the 40-meter line, and then back down to the 30-meter line, okay? So you should see this up, down in your graph. What is the independent variable and dependent variable in your graph? The independent variable is time. Remember, independent variable is always on the x-axis, where dependent variable is always on the y. Notice I also included my units. Make sure you always include your units. So time in seconds, and then distance from the starting line is your dependent variable in meters. Activity B. Now, activity B, again, you're screenshotting graphs, so your graphs don't have to look identical to mine, but they should have the key features that mine do. So, create a graph that a runner is moving forward, okay? So no matter what, your graph should have a line going up from left to right, okay? So this graph has a positive slope, and the line will go from the lower left to the upper right, and that's how you know the runner is always moving left to right. How do you know if the runner is moving right to left? So right here, we have a line that starts in the top left corner and goes down to the bottom right. This runner is running right to left, and this graph has a negative slope. And that's because that line is decreasing from left to right. And then the next one, we had to make a runner pause, rest for a couple seconds, okay? So how does your runner show that they are at rest? The line will be horizontal when the runner is at rest, and that is a slope of 0. In general, how does the distance time graph show you the direction the runner is running? If it has a positive slope, it indicates that the runner is moving forward. Negative slope indicates the runner is moving backward. And a slope of 0, which is a horizontal line, shows the runner is at rest. Okay? So now you had to create a graph. I'm sorry, the graph was created for you that included certain points. So where does the runner start? It starts at the 0 meter line, and where will it be after 2 seconds? If we look, 2 seconds, 10 meters. And then again, at 4 seconds, where is it? 40 meters. At which time interval do you think the runner will be moving most quickly? The correct answer is 2 to 4 seconds, because if you're looking at these two chunks, so from 0 to 2, and then 2 to 4, this 2 to 4 portion of the graph, there is a steeper line. So you click start, watch the animation. What do you see? You should see the speed of the runner increase after about 2 seconds. How do we calculate speed? You started this last week prior to doing the Gizmo. Meters divided by, or distance divided by time. So in the first 2 seconds, how far did the runner go? 10 meters. Each second was 5 meters, so the runner was running 5 meters per second. The last 2 seconds, they traveled 30 meters. In each second, it went 15. He went 15 meters. So the speed of the runner was 15 meters per second. So again, the steeper the line on the graph, the faster the runner, which we already talked about. And then activity C. Activity C, again, you have a lot of screenshots you have to input. So again, as long as you have the main features of my graph, you're fine, okay? So we need to create a graph that runner 1 wins the race. Runner 1 is red, runner 2 is blue. Red reaches that 40-meter mark first, so therefore runner 1 wins the race. Runner 2 wins the race. Again, runner 2 is blue, so it reached this 40-meter mark prior to runner 1, so runner 2 won the race. Runner 2 catches up and passes runner 1. So see how these two lines intersect. Runner 1 is red, and it's kind of just going at a consistent pace. Runner 2 is blue, and as you can see, it's behind runner 1. At this intersection, they're at the same distance at the same time, and then runner 2 passes runner 1. Runner 2 is going in the opposite direction, so remember, direction is dictated by slope, so runner 2 has a negative slope, so therefore it's going in an opposite direction. And then each runner goes at a different speed but reach the finish line together. We have runner 2 starting ahead, but they do reach that 40-meter mark at the same time. Based on your answers, on your experiments, answer the following questions. How does a graph show if a runner gets a head start? Right here, see how runner 2 started higher up on the y-intercept? That shows that the runner got a head start because it started 20 meters away from the starting line instead of at the starting line. How does the graph show which runner is faster? The steeper the slope, the faster the runner, the greater rate of change. How does the graph show the runner winning the race? The runner reaches that 40-meter mark first. How does the graph show the runner going back and forth? That line goes up and down. Now, we don't really have a graph where a line's going up and down, but just keep in mind that positive and negative slope. And then what does it mean when the two runners' graphs cross? That's when one runner passes another because they're at the same distance at the exact same time. Okay, I hope you did not forget to do your 5-question multiple choice assessment. If you did, make sure you go back and do that now. Tomorrow is a flex day. Make sure you review this because you will have a concept check on this Thursday. Okay, have a great day, guys.